And graphing, finally graphing trig functions. We know that we're graphing the sine, so we know we have to find the period. The period is 2 pi over b, and b is the number right in front of the x, and b happens to be 1, so 2 pi over 1 is 2 pi. So we're going to mark it off, and probably easiest to mark it off. 1, 2, 3, 4, 7, 8, 9, 10, 11, 12, 13, 14, 15. It would have been nice if we had this marked off 16. I'm going to add one more here. I'm going to add one more. It's nice if it's 16. So I'm going to go over 16, and I'm going to go, I know I'm going to have to go, I'm going to go pi over 4 to the right. So I'm going to go over to 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that's going to be my 2 pi. And then 6 then, 1, 2, 3, 4, 5, 6 would be pi. And then pi over 4. Sorry, pi over 2. And then we have 3 pi over 2. So that's the first thing I do, is mark off the period, as well as divide the period into 4 equal sections. Now, I know my amplitude is 2, so I'm going to go over here up 2 and down 2 as well. So now I can just go ahead and graph y equals 2 sine x. Forget about the horizontal shift for a minute. And graphing 2 sine x, I know it's going to go through 0, 0. And it's going to go up first, then back to the middle, then down to the bottom, and then back to the middle. So my rough draft before my horizontal shift looks like this. But again, we're going to shift this pi over 4 radians to the right, because that's the phase shift. The phase shift is c over b, which is pi over 4 divided by 1, because b is 1. So pi over 4 radians, well, that's why I wanted 16 here, because now I have to cut this in half. But nevertheless, pi over 4 is in between 0 and pi over 2. So at this point, once I've counted off pi over 4, let's put this in green, the rest of them. Pi over 4, I know that from the beginning, 0, 0, to the first little notch is pi over 4 radians. So every time I go one more little section to the next little notch on the x-axis, I'm going pi over 4 radians. So if I go 1 pi over 4, 2 pi over 4, 3 pi over 4, 5 pi over 4, 6, 7 pi over 4. So you have to make sure 8, 9, you have to make sure 9 pi over 4 and indicate what the x coordinates are for each of the 5 key points. So if we're going to move this graph to the right pi over 4 radians, we move each of the 5 key points pi over 4 radians to the right. We're moving it to the right because of the minus sign, and so this gets moved to the right, this guy gets moved to the right. We're going to go 1.5. So 1.5, which is pi over 4, little marks on the grid here. From this point here, 1.5 goes over pi over 4. This point down here goes 1.5 to 7 pi over 4, and this one goes up to 9 pi over 4, and we just draw the graph. And again, if you miss it a little bit, just make the dot bigger. So on the interval from 0 to 2 pi, okay, on the interval from 0 to 2 pi, the domain is all real numbers. The range is from -2 to 2. Increasing. So if we are using 0 to 2 pi, then you actually have to do one more thing than we're used to, and that's just extend the graph back to where it hits 0. And so it's increasing. This function is increasing from 0 all the way to 3 pi over 4. And is there another interval in which it's increasing? So back to here. So yeah, so we backed up pi over 4, so we start from the bottom, go to the bottom, so it's not increasing again. Oh, I take it back. It is increasing up until from 7 pi over 4 to 2 pi. 7 pi over 4 to 2 pi. It's increasing. Okay, decreasing from 3 pi over 4. We can see the y value is getting smaller from 3 pi over 4 all the way to 7 pi over 4. The x-intercepts we can see are at pi over 4 and 5 pi over 4. The y-intercept is at -2, 0, -2. Maximum value is 2, minimum value is -2, the amplitude is 2, and the period is 2 pi. There you go.